Thanks everyone for coming. I'm going to be talking today about, versus some of the other lightning talks we just heard about how to implement security in Jenkins, I'm going to be talking about how to keep Jenkins itself secure in some very targeted ways. My name is Alex Thurlow. I'm an engineering manager in the delivery engineering group at Indeed, and I help people get jobs. And I do that by providing the software and infrastructure to help our product teams deliver high-quality features quickly. Now, one of our primary goals is to keep our development teams happy. We want happy developers. How do you keep developers happy? You let them do what they need to do. You give them a system that has a lot of freedom. They can make anything happen that they want to get their job done. You know who else likes open systems? Is hackers. You have a lot of bad actors trying to get in, and if the system's too open, a lot of bad stuff can go on. So we have this push and pull between happy developers, open system, and not letting bad things happen within that system. So what do we do with regards to Jenkins in that? We have to build as if the users are malicious. That sounds bad, sounds maybe worse than it is, but it's a fact of life. And it might be that just in a large organization, yes, you have somebody who's truly malicious. It's more likely somebody's machine is going to get compromised. You're going to have a bad actor in the network with someone's credentials. There's your malicious user. So how do we protect Jenkins from those users? One, we don't implicitly trust user code. Build scripts, unit tests, job configurations, anything the user can edit, we don't fully trust. We let it run, it's got to run, but we don't trust it. And accordingly, we don't want to give any of that code elevated privileges. So it has enough privileges to get the job it needs done. We don't want devs to have root access to any of the build systems themselves. And in this age of microservices and libraries everywhere, you might have hundreds or thousands of builds. You don't want every developer to be able to affect every build. You only want them to be able to affect the ones they're supposed to. So for instance, I don't want to grant a brand new developer the ability to put code into our billing systems. That would be bad news. So we want them to only be able to affect their own jobs. Let's, quick reminder, look at kind of what a Jenkins configuration, a Jenkins file system looks like. You have some configuration, you have some credentials. Those are especially present on the Jenkins masters. And then you have project workspaces. So this is where you've cloned code. This is where builds happen. They're all in this one big file system. And if you set up a default Jenkins install, you're leaking all your credentials. You can go through the file system. If you run builds on your master, by default, you'll usually find that this credentials file is fully visible and readable. Additionally, you can do basic directory traversals, and you can hit all the other workspaces on the machine you're on. This is on any build machine. Anywhere code is cloned, you can get to it from every build. So do we need to remove the user's permissions? Do we need to not let them use shell calls in builds? No, of course not. That's why we're here. We're going to talk about how you let that work. So we secure our machines and our workspaces with Docker. Buzzword everywhere, Docker, it's useful. So instead of running the Jenkins build process directly on the machine, we run it in a Docker container, and we mount in only the build workspace that's relevant to that job. So that way the build code is contained. It can't hit the outside system, but it can touch all the files it has to. It can't get to anything else. And additionally, some of our more paranoid builds might do actions in the ephemeral Docker file system. So that way, even if a process on the host machine goes to try to affect the workspace, it can't affect the build in flight. Something outside can't easily affect that ephemeral file system. And so we have this nice sandbox. Builds can't affect the system, and builds can't affect each other. They can't go all over and read everything out of every directory. But we have a big problem. Docker is extremely powerful. If you have the ability to run Docker, you have a lot of privileges. To keep it short, if you can do Docker run, you have root access. If you don't believe me, try running this. You'll find you have full root access on your entire file system. Doesn't matter if you wrap it in a Docker group or anything like that. That's just a fancy way of saying, yes, you have root. And you might try to solve that with Docker in Docker. But at that point, you are running a privileged container with a privileged user. You have access to proc, sys, and dev, and all that. Full read-write, again, equivalent to root access. So we can't allow our users to craft arbitrary Docker commands. What that means, so we use CloudBees Jenkins, the commercial one, has a concept of Docker agent templates. We only allow admins to create those, which means we can control kind of which Docker commands are set up to run the builds. Using pipeline scripts and other plugins, there's going to be some other ways to do that. We do it a specific way. But again, you're thinking, okay, I can't run Docker commands. How do I deploy Docker images? We have Kubernetes all over this conference. You can't deploy to Kubernetes without building a Docker image, so you need to be able to do that. So how do the developers build Docker images? Quick reminder of how Jenkins and kind of how the industry recommends that you run Docker from within Docker. The recommended way is you mount the Docker socket from the host into the container. You additionally mount the workspace from the host into the container. This funnels the Docker commands to the host machine where they actually occur. So, based on what I previously said, you're now breaking the walls of the container and you're allowing somebody in the container to have access to the host machine again. Really bad news, so we can't do this. But what we realized is that there are safe Docker commands and there are unsafe Docker commands. So everything you need to do for a deploy is actually safe. You can allow build, push, tag, pull. Those are fine. It's run and exec that are problematic. So we wanted a way to just allow the commands that people actually need and disallow the others. We found an open source project that exists that helped us do this. It's called the Docker Socket Proxy. Apparently, Docker Enterprise implements something very similar to this if you go pay for that. But there is an open source tool to do this. And we've implemented that into our system in a similar way to how the Docker socket worked before, but a little bit different. So we mount the Docker socket into the container, and then we start up this proxy. It's an HA proxy with a special config file. It proxies the Docker socket to a TCP port. We drop the user into the container as an unprivileged user that can't access the socket. But they can still send Docker commands to this TCP port. Docker doesn't actually care. It totally works over TCP. So they send a command, and the HA proxy only lets through the safe ones. It lets through build and push and all the safe APIs, and actually only works on a whitelist. And then it just, if you try to do run, you try to do exec, it just rejects it. And so that way, even though you're executing Docker commands on the host machine, you're not actually really allowing anyone to break out. You're just allowing them to execute Docker. Additionally, there's a nice bonus here. When you do the Docker socket mount thing that's recommended, if you do Docker login, your credentials get saved to the host machine. So everyone doing Docker on that machine gets all shared credentials. So you might be able to gain access to some registry path you're not supposed to have access to. So the nice thing here is we can send the credentials directly along with the Docker calls. They are then only available to that build at that time to nobody else. And we can use secure Jenkins pipeline methods to inject them, which means that not even the user running the job can see the credentials if we don't want them to, which is a really good extra layer of security for us. So I just told you a bunch of problems, and I had a bunch of layers onto your build. Was there any benefit at the end? Well, we ended up where our users can still create and configure all their own jobs. They can do what they need there. They own their own build code. That's all safe. And they can build and publish Docker containers to allow them to use these modern deployment systems. At the same time, they can't compromise the build machines. They can't see credentials they shouldn't be able to see. And they can't sneak code into other projects. And we've done this in a way that's mostly invisible to them, to where they're still happy, they can still do everything they need to do. So I think that's a win. And that's it. So thank you. Any questions? I thought about doing it, but one day might turn into a blog post.
So what was that open source project you guys were using?
Yeah, I can go back to that. It's here, Technativa Docker Socket Proxy. It's super cool. We thought about ways you could use like a set UID binary that does a similar thing, but this is kind of a nice pre-built solution that actually worked well. We took it and shoved it into our own specially crafted container, but you could almost use it as is. Great.
That was great.
Thanks. I'll be hanging out if anyone has any questions.